Hello, my friends. So today we're going over problem 2.6. Okay, so the problem goes like this. Steel tank is to be positioned in an excavation, similar to the image. Knowing that the magnitude of P put some notes. Is 500 pounds. Determined by trigonometry. A, the required angle alpha, if the resultant R of the two forces applied at A is to be vertical. Okay. And B, the corresponding magnitude of R. Let's import SymPy and then do something very, very similar to what we had. So P, symbol P. Actually, this time what we want is alpha. And P is what we know. So 425 with 30. Let's actually, yeah, so we know that they are in the opposite directions. And the 500, and we know alpha. That will be a little bit of a headache, but it's okay. And we will see why, because alpha doesn't go with an numpy radian. Okay, so instead of that, let's do course math. And let's do, actually, let's do from math. Course cosine and radian. Let's do this. Can't convert expression to float. So then does SymPy have fine? Yeah, okay. So this is then what we were gonna do. Let's import cosine and we will deal with radians. So def radians return the angle times a pi over 1t. And this and then we can for the one. So there are two solutions to our equation. it's either 42.6 or 317.4. And we know for sure, like we know that this is our 0, right? So when we start going this way, the 42.6 will be somewhere here, while the 317 will be the opposite direction here, which means like it will cancel it in the y, and this is let's say the requirement that we put, but it might also cancel it in the maybe not cancel it, but the resultant might not be positive. So from that we can decide, or we can choose and know that our right solution is the first one. From there we're gonna do the following. Actually, let's go here and take this. We've been taking this around B, or B, let's do this, and we don't need to think about it now because we know exactly, like we have built these functions before, so we don't have to rethink it again. And what we're going to do is call the first one Q and call the second one P. And similar to the previous, we know that the magnitude is 425 and the direction will be 180 minus 30. And the reason is that we, as we mentioned, our convention is to take the angle always from the positive x and counterclockwise. So the angle for this one, or as we are calling it down, Q, will be 180 minus 30. And that's why this is the direction that we're using here. For the magnitude, we know it's 500 for the P. And the direction and we get our resultant, which will be 550.92, and it will be at 90 degrees, which means it will be in the positive y direction.